For those of you joining online, can you hear us now?
Yes, we can.
Okay. Oh, very good. Thank you so much. Do let us know in chat if something goes wrong with the Zoom or the audio becomes unstable or you can't hear us anymore. So here we are again. I was just dealing with some logistics in the room, so those of you joining us online, you didn't miss anything. Good morning, everyone. We're very excited to continue our learning and engagement sessions, these panel presentations that are follow-ups from our original solution set plenary that we had in April, that whiteboard exercise. And you'll recall last month we had a really good conversation with the conjunctive use panel. Today we're continuing with two more panels from ideas that came up at the whiteboard session. Hopefully you all have the agenda. For those of you who are joining online, we provided 3 documents: the agenda, the index that we've put together, and the backup for the index, which is the raw data that came out of the whiteboard exercise. So those are all of the materials that we provided. And so today we are going to have 2 presentations. They are focused on possible solutions and ideas related to upstream reservoir operations, flood management, and flood managed aquifer recharge. That's our first panel, and I will allow our moderators to introduce the topics more specifically and to introduce the panels. And then we have a second panel that's focused on cold water management, what to do about the temperature problems in the American River system, the lower American River in particular, and we have a panel of 3 with a moderator, Ann Sanger, for that one. So for this first presentation, this first panel presentation, I'd like to turn it over to Tamika Lecluse, who is our moderator, to introduce the topic and our panelists. And just make sure your microphone's on.
All right, can you hear me? I can hear me.
I'm so sorry. I'm just like so excited about these panels this morning that I skipped over our welcome. So Jessica Law will be welcoming you, and then we'll go to you, Tamika.
That's right, Tanya. You said everything that I was going to say. So I just want to say welcome. It's really good to see everyone here, both online and in the room. We've got a really good cross-section of the different caucuses, members new and old. So for those of you in the room, if you don't know somebody, please go and introduce yourself. We really want to be sure to, these are great opportunities to be able to connect on a one-on-one basis. For those of you online, thank you so much for joining us. This is basically the second plenary in a series of 3. And again, that whiteboard exercise where we generated the 118 ideas. These are really distilling those ideas. Today, you're going to hear kind of a different style of discussion around solution sets. This is this panel and the next panel has a really high level of expertise around sort of very technical solutions. Some of these are new solutions. Some of them are solutions that have been around for 20 plus years. So for all of us, really be listening for where we as the Water Forum go with this set of solutions. What can we do? How can we control? How can we influence? What's our role in this, looking at these solution sets going forward? So with that, thank you, Tanya and Sophie, for all the setup. Huge thanks to SMUD for letting us do the meeting here. Again, it's a really great facility. Those of you in the room, food, restrooms through there. And I'm looking forward to the discussion. So with that, go ahead, Tamika.
Thank you. Good morning, everyone. My name is Tamika Lecluse. I am a trustee with the American River Flood Control District. And today, I'm so proud to introduce Gary and Darren, who will be talking about upstream reservoir operations, as well as flood management, flood mar, and using technology and new tools for forecasting. And I believe it was the April plenary. A lot of folks had some questions about how flood management, hopefully works with the co-equal objectives. And we know and we anticipate that there will be greater variability of water conditions, more extreme high and low year, wet year. Can you hear me? Are we good? This one?
Yeah, we're having some issues with this mic. Can you try that one?
How's this? Is that better? Oh, hey, I've got two mics. This should be great. Given some of those principal problems, more extreme weather variability, more dry years and wet years, how does flood management around the region achieve our goals as a coalition? And so first we're going to hear from Darren Reintes, who is the Director of Resource Management for the Placer County Water Agency. Darren has been with PCWA since 2006 and is currently responsible for overseeing the planning and stewardship of the agency's watershed resources, which include water supply, production of hydroelectricity, recreation, forest management, and regional water and energy matters. Darren has a BS in Applied Mathematics for Science and Engineering from CSU Long Beach and holds a professional license as a civil engineer with the state of California. Gary Bardini, next to me, is the PE Director of Planning with SAFECA. Sorry, I don't have my acronyms here. Gary has been with SAFECA since September 2017, and with 37 years of public service with the state of California and the Sacramento area, providing strategic planning, policy development, and engineering services to promote integrated and sustainable management of the state's water resources. At SAFECA, he directs the formulation, refinement, coordination, and policy administration for their strategic and project-level planning initiatives. Prior to working for SAFECA, he served as the Integrated Water Management Deputy Director for the California Department of Water Resources from 2011 to 2017. He's a professional engineer and graduate of the Cal Poly, San Luis Obispo, and he has his bachelor's degree, Bachelor of Science in Civil Engineering. So welcome to both Darren and Gary.
All right, sound check. All right, I think that works good. Thanks, Tamika. So I'm going to start off today with not necessarily the solution set, but more of the background on weather forecasting and the tools that help inform what Gary is going to be talking about, which is more of the forecast-informed reservoir operations, flood mark components of these solutions. And so I'm going to move through these kind of quickly. As my boss tells me, I have way too many slides every time I do a presentation. So next slide. Or do I have control? No. Okay. So first, I want to start with the challenges, a little bit of foundation here. And so in 2014, Bureau of Reclamation did a basin study for the Sacramento-San Joaquin. That's the blue area there on the state. So you see it covers much of the valley and much of Northern California. And the results were somewhat shocking as far as the future climate conditions, and the modeling showed, increased temperatures going out to the end of the century. Overall precipitation showed, not much, I guess on average, not really an increase about what we've seen, but what it did highlight is, or an expectation of more extremes, so more droughts, more floods in that sense. And so, and then here locally, we saw this and said, okay, we want we want to downscale that, look more closely at our region, considering Folsom Reservoir is our main water supply reservoir, and it's fairly small for the basin. And so we engaged in the American River Basin Study, which most of you have probably are somewhat familiar with, but and that report took a while to get finalized, but was released almost about a year ago, so last year. So next slide. And so to get to the punchline, what the results of the study showed that in the basin, we anticipate, based on these climate models, increased temperatures throughout the basin. In particularly the increased changes, the higher in the elevation you go, the higher the increases in temperatures. And so this plot here is showing you anywhere from 5 to 6 degree change in temperatures by near the end of the century. Next slide. And so what that means here for the state and here locally, again, we're a snow dominant system with a small reservoir, in a smallish reservoir in the basin. And so these images kind of depict an example of what we could be seeing in the future conditions. And so the picture on the left is, this is probably just a typical average winter where much of the Sierras are covered in snow. That arrow there is pointing at Folsom Reservoir, which at this scale you can't even see. And then on the right is a depiction of really what we think these climate change studies are telling us of what we should expect more often. Next slide. So how this relates to water supply and flood management, this plot here came out of the study, and I know some of these, this is kind of hard to see part of it, but what this is showing here is, and so this is a depiction of the water year, so from left to right, a timeline, October through September. The bubbles there represent volumes of runoff in a particular month. And so the gray bubbles there are the historical data, and what you see there is the larger bubbles occur, so the greatest runoff generally occurs in the April and particularly May timeframe. And so you build that snowpack, it warms up, it melts off, and you're seeing the majority of that runoff in the May. And reservoirs are filling and generally topped off in late June and July. Jump down to the bottom, the yellow bubbles there, and you can see, based on the central tendency modeling, what we're seeing is near the end of the century, there's a shift in when that runoff occurs. And so now you're seeing larger bubbles and the bubbles occurring earlier. Particularly, you can see there late December, January, February timeframe, which is our winter. That's the time when we're typically storing snow and reservoirs are lower. But what this means is, we anticipate seeing a greater flood risk, more flood releases in the winter and spring, and that leaves less water for water supply operations in that late season summer. Next slide. And so just to wrap that up, again, here's kind of maybe the picture on the left is maybe not what we expect to see every year, but, that's a look at Folsom in drought years, and in the right, a look at Folsom in the wet years. And so, as I mentioned, with climate change, we anticipate seeing these extremes more often. Next slide. And so forecasting is important for reservoir operations. And what this is here is a slide from NOAA, and so I'm going to move into the forecasting side now. So a runoff forecast, what we're using to help us guide our operations, it's a combination of weather forecasts and then river runoff forecasts. And so the National Weather Service, who's doing the weather forecasts, they're here in Sacramento. On the same floor in the same building, you've got the River Forecast Center just actually in the same room. So they're collaborating on these forecasts and river forecasts. And so the top section there is really just is more of the weather forecast. And so you can see under weather forecast there, it says, you've got your forecasters doing these short-term weather forecasts, the 0 to 5 day, which have more confidence. So, if you look at your phone, you've got a weather forecast, right? And it's just one forecast. It's not a range of forecasts. when you look out beyond that, out towards 2 weeks, the forecasters are relying more on the models to really dictate the range of scenarios that go into these runoff forecasts. And then on the far right side, as you go out further into the year to the end of the year, really what they're looking at is just what's happened historically, what are the climate-based forecasts. And then on the bottom, the River Forecast Center, they incorporate that data into their models, and I'll talk a little bit more about that in another slide. But so that's the input into their models, which they're accounting for what are the current conditions. And so they're looking at what's the snowpack, what's the saturation of the ground, how much water is in the reservoirs, what are the temperatures, and then they're using that and running that through their models going forward. Next slide. And so the first part I mentioned was the weather forecast. I'm not going to get too deep into that. I'm not a meteorologist, but essentially what they're doing is the short term. They've got these models, the GFS model, the European model. They've got these handful of models that they're using to inform their forecasts, and it's an ensemble. So it's running many different scenarios, and then statistically it's coming up with the most likely forecasts. And then on the right is the an example of what the seasonal outlook, so the long-term outlook looks like. And so California is very challenging to forecast out multiple months. There's a lot of factors and drivers, sea surface temperatures, you hear about El Niños and La Niñas, Arctic oscillations, all these, snowpack there's all these factors that drive long-term forecasts in California. And any week those conditions can change and completely change what the future forecast is. So my meteorologist is probably can't stand me because he says it's going to be wet. I say, well, I'll bet you it's going to be dry. It's very challenging. Sorry if there's any meteorologists in the room. And so what you'll normally see on a long-term forecast for California is just that white on the right, which means equal chances. And so even the Weather Service doesn't want to make a strong prediction one way or the other. Next slide. And so don't expect you to really see anything there on the left other than this is just an example of the River Forecast Center. This is their physically based model where they're ingesting all that information. What you're seeing there is, we'll call them buckets of water. And so those are the different states within the surface water system, the groundwater system, evaporation. They're looking at all these things and they're running it through their physically based model. All that's feeding into the river, accumulating downstream on the right to help produce these forecasts. On the right is an example of a long-term, based on all those weather projections, a range of outcomes that you could see as far as runoff. And so this is an example of a fulsome runoff projection. You can see there's just huge variability in what the projections look like throughout the year. Next slide. And so these are, again, products of the River Forecast Center. And so on the left is a short-term forecast, and it's showing a range of possibilities based on the models. The dark line there is, the weather forecasters really, choosing their deterministic model. So based on what they're seeing, they're thinking short term. This is more than likely what we're going to see here. And then on the right is the seasonal forecast, and it's take me a second to explain this, but the dots are essentially, and again, this is a water year from left to right, October through September. Let's just look at November. So November 1, just to the far left of the graph. What this is saying is it's showing that this is for a water year runoff projection. The green dots are the median, the 50% exceedance projection. And so what it's saying is if from that point forward, if conditions were normal or median, you should see whatever the green dot was in November. So far left, so close to 300,000 acre-feet, which is near the mean, which is the dashed line. So that's expected, right? Early in the season, if you get average conditions, you should get average runoff, right? The red on the bottom, if you go down, that's saying if it's a dry year going forward, and again, these projections are going forward, if it's a dry year, you should only expect to see 150,000 acre-feet. And this is an example for Hellhole Reservoir. And then on the top, the blue ones are, if it's a wet year, you should expect to see 500. And then as they go throughout the year, they're updating their forecasts. And so these are, they continue to update these forecasts. And by the time you get to the spring, you've got all your snowpack. You pretty much know at that point, they're converging. You pretty much know what your forecast should look like. So in this scenario, it was a dry year. So throughout the year, it continued to be dry. And by May, not a lot of snow. This is 2021. And the projections, the 10, the 50, and the 90% exceedances were starting to align. They should be aligning that the runoff for that water year is going to be, roughly between 150 and 200,000 acre feet. So, so how are we using these here, for water supply operations? Next slide. No, not quite yet, sorry. So, no, yeah, next slide. I teed myself up too early. So this is the River Forecast Center. So they're doing this throughout the watershed. And so within the basin, they're doing this same thing throughout 15 watersheds and 24 sub-areas in the basin. And so they're doing this modeling for each of these sub-basins. Next slide. Running it through their, routing it through their model. And so far right side is the upper reservoirs. You've got French Meadows on top, Hellhole, Loon Lake, going down Union Valley and Ice House. And so they're routing all these forecasts all the way down through the system until you get to Folsom Reservoir on the far right. Next slide. And so how are we using some of these tools and projections? And so here, so this is specific to PCWA. This is our reservoirs, French Meadows and Hellhole. This is an example of 2019. So what you're looking at here is reservoir storage. So the dark blue is reservoir storage throughout the water year. The dashed line up there is the capacity of our reservoir storage. The white line is the snowpack conditions throughout the year, and so a snow water equivalent. So how much water is in the snow above the reservoirs. And if you combine those two together, if you stack them, you get the lighter blue reservoir plus snowpack. And so what this is showing us is that, we had more water in the basin than above our reservoirs that we could store. And so this, along with the River Forecast Center projections, our meteorologists' guidance, we, in 2019, we're using these to inform our reservoir operations. And in that year, we managed to keep the reservoir lower as long as we could. And where most of the reservoirs in the state were spilling in 2019, we managed to just barely reach the top of our capacity and not spill that year. Next slide. And so I'm going to wrap it up here just with some recent advancements. And so a lot has been going on in the last 5 years, both in universities and implementation. Data and processing, machine learning alone have just, come leaps and bounds on what you can do with models and data collection. And so a couple of examples on the right, and there's others that are happening, but particularly that I think that we're really interested in right now is the Airborne Snow Observatory, or ASO, and the atmospheric river research and monitoring that's going on through CW3E, which is the climate and weather extremes with UC San Diego and Scripps Institute. And so just a couple slides on these, just informative. So the Airborne Snow Observatory, this last year in the American River, we did our first flights. And so this was developed about 10 years ago. It's been piloted. DWR has shown a great interest in it after the drought, and they got a lot of attention in the media for blowing their forecasts, essentially. And so they've definitely they're sensitive to that. They've done a lot of work in the last couple of years to improve on those, and one of those is this Airborne Snow Observatory. And so now, as I mentioned, this last year we were doing this in the American River Basin, and what it is essentially, it's a plane flying over with a LiDAR scanner, and next slide. It's giving you these, so it's just flying, scanning, and it does this every month, and it's showing you exactly how much snow you have in the basin. So where we were relying on sensors and monitors, in a few places throughout the basin, now we can look at pretty much every square inch of the basin to figure out how much snow is there. Next slide. And so this is an example of what we get out of that. So the data to develop these types of this information and these plots is just enormous, and just the computing power and the processing that the advancements has allowed us to do something like this, where we can produce these maps and you can look anywhere in the basin and see exactly how much snow is there. Red in this case being the deepest snow, down to white being the least amount. And so just really cool stuff going on in the basin to help inform and improve on our forecasting abilities. And then lastly, I'll end with the atmospheric research. And so I think I'm out of time, but so just really quickly, there's been a lot of research. Scripps and CW3E, I mean, they're basically treating these atmospheric rivers like hurricanes. And so they're studying them like hurricanes. They're dropping sensors. They're flying out on the left. There is a study area during a particular storm. They're flying out there and dropping sensors. So in this case, they dropped, I think, 30 sensors into the storm drop-zones that are monitoring atmospheric conditions so that they can better inform how is it going to, when and what's the intensity of these storms hitting landfall. Next slide. And just some other plots. These are, I'm not going to get into these, but really just showing intensity, timing, and where along the coast and where this is going to hit California. Next slide. And I'll just wrap it up with this. Just more slides on looking like when it does hit. Just look on the right side. That's basically showing the vapor transport. How much water is in these storm systems that are now hitting landfall. And so these are just these recent efforts are just drastically improving the type of forecasting we can do, which will better inform our reservoir operations, our flood management, and really are the foundation for this FERO or this forecast-informed reservoir operation that Gary is going to get into next.
Thanks so much, Darren. We will have an opportunity for Q&A after the next presentation, so I'll just hand it over to you, Gary.
Okay.
Well, thanks. Anyway, I think I'd like to kind of really just build off what Darren has just presented. I mean, it shows you a little bit of the progression of the art of forecasting, and really how do we make that actionable in res management, which is what I'm going to try to cover, which we call forecast-informed reservoir operations. In the case of the American River Basin, this has been a progression, and I'll go through that progression. A lot of it started with my colleague, Tim Washburn, and others with the JFP. But before I go into that, I thought it would be maybe just to take one step and give you all a little bit of context in flood management, which was part of the request for the presentation. So I'd like to cover that and a little bit about how it fits within working in the system of federal and state government, which is part of the flood control system and the management of it. And then I'll go into the FERO, and then I'll talk a little bit more about what we would call watershed FERO and managed aquifer recharge. So maybe just next slide here. I stole this slide from Les Harder back. This was essentially right when we started the Flood Safe initiative. But I thought this was a good one because it kind of reflected really the situation of flood management. While SAFCA, which was created after the '86 flood, where we had a very, very close call, was really took initiative that we're now seeing a lot of that fruit of that over the last 30 years. But I think, for the country and then even for the state, there was generally a pretty laissez-faire feeling about flood. And so really Katrina was really a big change. There was also a white paper done by the state that we did in '05. It's called the Flood White Paper. It highlighted the flood crisis. And so I think it's been a combination of things that led into a significant amount of investment by the state and the federal government in the flood control system. Go next slide. So a little bit on the SAFCA program is, SAFCA is trying, as we've gone through the climate uncertainty and change that we're seeing, we know the intensity. SAFCA has been progressing to an objective of 500 level of protection. Right now, the city is still, in many areas, while we're making improvements, is still not even at 100-year. But we think in the next 3 years, we'll be up to about 300-year protection with finishing the projects at SAFCA. So these have been either around channel improvements, levee improvements, storage improvements, and then the bypass itself in the weir. So a lot of these things have been some of the foundational things to improve protection in the region, but that's not enough. So we've been looking more system-wide at broader protection, and that means looking at the broader bypass of Yolo bypass expansion there. The state's taken initiative on that, and we're looking to have a comprehensive study right now with the Corps of Engineers in the state. And then what we're going to talk a little bit more then is looking at what we call the American River Watershed Forecast Informed Reservoir Operations, and how do we squeeze every aspect of what Darren just went over, which was essentially the state of the science today, and how do we apply that moving forward in our current infrastructure or making additional infrastructure improvements to leverage it. I'll go to the next slide. So this slide here is actually from the state of California as part of the Central Valley Flood Plan, and it kind of reflects the state's philosophy of investment. And it kind of shows what SAFCA has been doing as an agency, working from the regional project level and the planning all the way up to the comprehensive level, where state and federal government. And so a lot of ways we're here today to talk about what we're doing at the region, but as we move these types of projects to implementation, it requires a lot of alignment and funding and support through the federal and state infrastructure and agencies. So just a little bit of a context here of what's required to make these projects actionable, and it does take quite a long time. Just in the case of SAFCA as an agency, since 1989, it's been 30 years of ongoing efforts of progressions, working through the different bureaucracies and agencies to make things actionable. So it's a little bit of perspective. So some of the initiatives that we're talking about today will take, decades to continue. It's the science, it's the agency support and funding. Next slide. Okay, so maybe talk about the progression of FERO in the American Watershed. And I kind of want to talk in 3 steps. It's going to be what we just completed, which is the joint federal project, the big spillway project, and the photo that Darren showed, a little bit of the actual activities right now on the Folsom Dam raise, and then talk about Watershed FERO. Let's go to the next slide. So I just have, I went with the more simplified versions of what Darren, but I appreciate that Darren provided really that's the specifics that we're working with in terms of predicting what this simple visual is. But essentially in California, we have high Sierras on the far right, and essentially it works its way down to upper level reservoirs to then what I would call rim reservoirs, and then works through a flood control system, and then it makes its way out to the Pacific Ocean, usually through the Golden Gate here in the Central Valley. So go to the next slide here. Darren did a good job. I just did one simplified version of this year. This showed you the atmospheric rivers. This again comes from the CW3E folks at Scripps. And, just kind of gets to the tracking of atmospheric rivers and the state and science of doing this. It's greatly, where we've come in 20, 30 years is pretty amazing in this effort. So the aspects of taking this research and application of products and making it actionable has been a key thing with the Scripps folks. Just a little bit of context with that, they've done a number of efforts on other watersheds, Mendocino, right now Feather Yuba, Prado down. So there's a number of efforts to look at how to take these products, forecasts, and bring them into better reservoir management. And again, building on FERO. So look at the next slide. So this is a little bit of the progression of how SAFCA has been progressing FERO with all those agencies I talked about. So the first has been the joint federal project, and essentially that's a new spillway that allows us to advance releases that we could not do with the physical limitations of Folsom. And right now, then we've moved that approach, and I'll go into a little more specifics, and then we've moved into then another set of FERO application, which is due to a dam raise, but it's also due to channel improvements done on the American River. And then lastly, we've been working with PCWA and here with SMUD, looking at making improvements similar to the JFP at the upstream reservoirs, be it Hellhole, French Meadows, and at Union Valley, and being able to leverage the same approach that was done for the joint federal project, where we could advance release with better infrastructure of outlet structures that allow you to be able to take advantage of that storage during a flood event. So let's go to the JFP. So for folks that haven't been out there, the project essentially is, was about $1 billion of investment, mainly coming from the Corps of Engineers, state of California, and SAFCA. And essentially, what it does is it actually allows us to evacuate water out of the reservoir at a lower level than was historically been able to do with the existing outlet structures. And so what that did, we'll go to the next slide, it allowed us then to essentially come up with a new water control manual, which has great improvements of keeping storage up higher now than it was historically under the existing flood diagram. And essentially the FIRO part is that 200,000 acre feet of variable space that is driven by forecast, by FIRO. And the thing that's kind of interesting about this is the first application of FIRO for flood purposes, for flood operation specific, that was done. And so this was a big advancement, but I would sit there and say it was a very conservative approach, which I'll go into, to come up with that space. But it certainly it's a huge stride from where it used to be. So we'll go to the next slide. So just a little bit, I know I've given presentations in the past a little bit on this, but the fundamentals of the forecast of how that variable space is created in that water control manual is based on a forecast on the 75% exceedance. So we're only looking at one probability to drive the operation. They did a bunch of analysis and said, we're going to use that one to be the best driver for creating that space that I showed. But it's based on 5-day forecasts, and it's looking at volume, the volume of water that's likely to come in. And so at 300,000. So it essentially moves from a 5-day forecast of 300,000, and then we go all the way to 24 hours. It drives additional and higher releases as you get closer with more certainty. So that's the approach that was done by the Corps of Engineers and working with the Bureau of Reclamation in the state. Okay. So now we have a project that's currently under construction right now. So this is the Folsom Dam Raise project. It consists of auxiliary gate improvements and then also looking at levee or dikes in this case here at Folsom. And it's a 3.5-foot raise, which creates about an additional 50,000 acre feet or so of space. But there's also surcharge opportunities to go back further, so we could probably leave even more storage based on how you operate. So that's essentially what this project is allowing. So we'll go to the next slide. So the two elements to the water control manual for this update of using FIRO, one is how do you advance release above 115, which is the current channel capacity, and go up to 160,000 CFS, because that's where the new improvements allow that to be safely passed. But the question is, what time, based on forecast, do you want to make that higher release? So that'll be the body of work that will start, I would say, the next year or so, and it'll take multiple years to come up with what that approach is in the water control manual. The second one is tied to, no, hold back. Yeah, the second one's called the conditional surcharge. This is the storage component of the Folsom Dam Raise. And the surcharge is the additional backing water up. And the question is, how best can you use that storage space based on forecast? So these are the two fundamentals, using a lot of what Darren went over, that's with the research community and the forecasting and the working, but how do we take forecasts and be able to come up with the best approach in a water control manual to do it? So that'll be the work at hand, particularly working with the Corps over the next 3 to 5 years. Okay. So I did talk about, so while we really made great strides with the JFP, it really was a game changer for the region in terms of flexibility and for flood protection. But, and then with the Folsom Dam Raise, we're looking to be able to get maybe up to 300,000 or 300 year protection. But that's still not enough based on climate change and uncertainty and extreme precipitation events we know that are coming or have been coming. So that's why we've been looking at the upstream efforts. We think if we move the technology of 7-day and integrate that into the upstream reservoirs, working with PCWA and SMUD, we think we can basically make improvements using that forecasting. We think we can advance additional space for flood storage out of those facilities and then they get up to about 500-year protection. So this is essentially the initiative that SAFCA has been undertaking. Okay. So that's a little context of just FIRO. Now I want to kind of talk a little bit more specific about Watershed FIRO and a little bit more its implementation, and then we'll go into the Manitowoc for recharge conversation. So again, Darren did a good job of framing the basin study. The basin study did a good job of describing the climate vulnerabilities from some of the things that were shown in the modeling. And these things range from some of the vulnerabilities of the upstream watershed, the fractured rock, the wildfires, and then all the way down to what we're dealing here with the water forum about the American River itself, the health of the river, and all the way out to the delta itself. So these things, and then of course regional groundwater management and sustainability in the region. So these are just a number of the things identified in the basin study. Next slide. So I'm going to do, this is my only animation. We're just going to do the animation of these things. So there you go. But so you've got your upper watershed and the issues there that I just described. And you have the groundwater management and cases in the South County with overdraft still. And a lot of efforts all along the way that RWA is championing with other agencies. Again, dealing with the sensitive species and dealing with the urban flood risk, which I've gone over in detail. These are all issues. And I think the predominant thing, which Darren talked about, is that one of the things, we have a large watershed and we have a very small reservoir at the rim. And that's one of the challenges for the American River. So, next slide. So one of the things we did is we looked at the watershed FIRO, knowing of the improvements of the watershed, the data collection, all the science that's needed, the coordination of reservoirs management, dealing with forest practices. All those things are very important in managing to flood and water management. And then we looked at the improvement side of both FIRO, at Hellhole and Union Valley and French Meadows. And then we have the aspects of how do we translate it into an integrated management to Folsom operations to boot. That's the elements. And we kind of looked at that those efforts combined goes a long ways to help deal with the vulnerabilities due to climate uncertainty by how we progress those. So this slide is just to show that nexus to the basin study and how this one further advances to deal with those climate vulnerabilities. Next slide. Okay, so for the sake of just the simplicity of the effort, the linchpin to it is the better watershed FIRO upstream. But if we basically can advance that and come up with then res management flexibility at Folsom with conditional storage operations that allow you to go further, which is what Mendocino demonstrated, then that opens up then better opportunities for managing the American River, how the limitations and flexibilities of system issues that the Bureau has to deal with, and then how do we basically better link that surface storage operation to groundwater management. So we think those opportunities do provide itself, and that's essentially what SAFCA was championing in the American River Basin study, is to try to link these things together as a climate adaptation strategy for the region. Next slide. So again, just a reflection of the things that were looked at in evaluation at the American River Basin study. There were a number of other climate adaptations that were identified in the report. And then what we had was the dam raise, upstream reservoirs, and then management for recharge is one climate adaptation strategy that I just showed. So, but this was essentially in the basin study. I think it was a good first step in evaluating, I think, what we can do in the region to do those climate variability or vulnerabilities. And I think right now each effort is I think going in some level at all levels, progressing the region, and of course we're trying to progress the watershed FIRO effort. So next slide. And that's not the way that slide's supposed to look. Let me hit it again, see if it cleans up. There we go. Okay, that's better. Technology. So a little bit on the watershed FIRO and just kind of what we've been doing. One thing we've been working on, looking at the engineering of the upstream reservoirs. Darren did a really great job of covering the data collection of forecast efforts and the models that are needed. So those have been ongoing efforts that we continue to support. Today, we're here with the Water Forum 2.0 and other engagements are needed on the effort. And so those are things we've been supporting. And then really the key is taking everything on those first, 5 items and bring it into a viability assessment report on where the opportunities are. This is the process in which the multiple federal and state agencies come together to assess the viability of using FIRO. And so we're now moving into a phase to scope that effort and to start progress down what we call the viability and begin a preliminary assessment report and then to a final. And this, like I said, is a multi-year effort to do that. while we continue to look at the engineering feasibility of the upstream reservoirs and the improvements. And then, of course, the last part, all of this to be actionable, it needs to translate into an effort with the Corps of Engineers. We'll have to do this with the Bureau, and this will be where you have to update the water control manual, just like I described that we're doing for Folsom. So this is the process for implementing. Next slide. So a little bit on the aspects of the scoping of a viability assessment. So one of the key parties to this is using the folks at Scripps, the CW3E, but it's also bringing together the operational community in progressing this. So this is what's been done in other watersheds, and this is what we'll have to do for this region. Obviously, as we do this, we'll have to have a significant engagement as we progress this work for the community. And then, we'll move through a number of technical studies, probably building on some of the things that Darren showed and how that progresses. And then finally move to then a final viability assessment report. So this is what's on tap moving forward, next steps. All right. Okay, so as I promised, let's talk a little bit more about now managed aquifer recharge. So one of the fundamental first steps is the FERO portion, because that gives you the flexibility that takes in essentially the hydrology and the res operation and the facility conveyance. Those things are key to making an assessment then into the managed aquifer recharge. So what I have here is 13 items that the state of California, the Department of Water Resources prepared, as they call it, their flood MAR. These are the key elements that you have to kind of progress in trying to promote that kind of effort. There have been a number of demonstrations of doing this or trying. They just are working this in pretty good pilot on the Merced River that DWR has been doing with Merced Irrigation District. So, but these are the fundamental steps, and we recognize that while we're continuing to get the first key part up and the FERO part, looking at where groundwater and managed aquifer recharge could actually be connected to it, provide some real opportunities, we think, to deal with some of those climate stressors that we talked about. So you'll want to move in. So we've been doing at SAFCA, we've just been supporting the regional agencies, the SIGMA agencies. We've been doing a number of pilots about what's physically capable of doing that. And so we'll continue to try to work with the region there in an assistance role. So that they can see where the opportunities, where they can get to some readiness of being able to take advantage if there's additional flexibility in res management. Next slide. So a little bit on this is my last slide, which is just, it all sounds good, but it's all about money to drive this. And so I kind of want to give a little bit of a flavor of how things have been funded. The JFP is funded, and I kind of did it here, by mainly a core study and then eventually core funding, Corps of Engineers. And essentially, that's what I call as a directed funding through a process with the federal government. And then the state of California provides funding as a match and SAFCA. So this has been the traditional flood world. But as we move into a watershed FERO, you're looking at having to link multiple funding sources and other efforts to make it all actionable. And then it's not just maybe looking at getting federal support at a given level, but you have to then look at other programs. Right now, the state of California has recognized the dam safety concerns and the aspects of FERO as a tool for improving water management. There's funding now this year, or coming this fiscal year, there'll be a program to start supporting this. So we're looking at trying to maximize those funding sources in the near future to help promote it. So it's a little bit of shift that we'll still have to kind of work the existing infrastructure and funding sources that we've historically used for the current projects, but we're going to have to go further now and look for additional funds for other objectives and multi-benefits. So this is just a progression of it, and I just want to recognize that, the aspects of funding sources and alignments for looking at how we do the lower American River and res management, or stuff, those are things to be worked on and developed. So these are just kind of a little bit of just the funding and some of the things we have to traverse as a community to make things actionable. So that's where I thought I'd leave the presentation today and open up for questions. Thank you.
Thank you, Gary and Darren. We do want to open this up for some Q&A. We're about 5 minutes behind, but I think we can cut into the break so we give us the full amount of time for Q&A. So we'll just have a 10-minute break instead of 15. So let's start with in the room. Questions for both Darren and Gary. And you'll need to get a microphone. So Inga, I see your hand is up. If you want to pull that microphone and make sure that green light is on so everyone can hear you. So then I'll go to those of you online. Inga.
Gary, is there an estimated date for the final viability assessment?
Yeah, I would think we're going to try to issue a contract with the CW3E folks over the next couple months, and that would start the clock. And again, we'd have to, and then it's again lining up the operational community to work in that whole construct. The typical has been basically about 5 years to get to a final.
Thank you. One other thing, on the Watershed, Faro, and the managed aquifer recharge in the South American subbasin, what are the benefits also to the lower American River and the Delta?
Well, I think it's kind of I think there's a number of ways or practices that can go to translate for more benefit. One is just by having the reservoir to be able to operate higher will allow for some better temperature management, and I think the next panel, I think will go that much further. But we recognize that obviously SAFCA is connected on temperature management. We are doing the temperature shutter project with the Corps right now to assist on that issue. So that's an effort currently. But we think you can, and again, the body of work, we think there's opportunities to just take the flexibility of the conditional storage that could be generated for temperature management. The second thing, though, is the broader issue is if you have better groundwater management in the region, then you can do things where you can rely on groundwater during dry periods and then essentially keep water in the river. So those are some of the efforts that we think are opportunities.
Thank you. We'll go to Ron and then Greg online. Ron.
We've had this conversation before, so I'll ask the question again, nevertheless.
I should be prepared then.
Just for the room anyway.
Yeah.
You emphasized kind of putting together the finances for various kinds of projects, and you listed some projects, not necessarily all. I think there's likely also to be water rights challenges. Mm-hmm. And in some cases, with regard to projects that are contemplated in Reclamation's basin study, there have been projects looked there that have been intensely controversial in the past and are likely to continue to be so. So you have some water rights challenges in some cases, and you also have some political challenges on at least some of those projects. And it's a leading question. Would you agree?
Oh, I'll summarize. Would I agree that there's going to be a lot of challenges to implementation of these things? Absolutely. I do think, the conversation on how to take advantage of floodwaters is something that's ongoing at the state. How best, I know they're trying to do things to streamline those efforts or how you go about it in execution. I think also how the storage rights are used and how that works contractually, I think are still being worked out by the Bureau. So I think we're going to see some evolution. But is it a challenge? Yeah, absolutely. And I think those are going to be, and what flexibility you have with those institutions will dictate how much you can actually do in these things for benefits. So I agree.
Thank you. Greg?
Thank you, Tanya. Hi, Gary. Question on the dam raise project. You indicated that it increased capacity. I think it was by 50,000 acre feet or so. My understanding was the dam raise was specifically really only to increase freeboard and not operational capacity. Can you speak to that?
Yeah, so it's not to be able to hold water in that space. It's just to, during a flood event, that water would be temporarily in that space.
Right. So
I just want. So it's more flood storage.
Right, just to be understood that we're not increasing general storage in the reservoir by 50,000 acre feet necessarily. It's just for flood.
That's correct.
Okay.
Yep, that's correct.
Okay, anyone else online while we're focusing there? Any questions? Yeah, I'll come to you, Barbara, in a second. Checking with anyone else who's online. Okay, coming back to the room, Barbara, go ahead.
Gary, you mentioned in order to pursue greater range of funding sources in the future that you'll be looking at more multi-benefit projects. Can you give us an idea what kinds of things you'll be targeting?
Well, I think like currently right now, it seems like I described the dams, there's emphasis on dam safety because of the Oroville incident and the outlet structures and other facilities. So right now there's been an effort by a lot of reservoir operators to seek state funding. So right now there's a public safety side, dam safety side, and then of course FERO's coming. So that's one element that we're seeing state action. A second one that we've seen, there's been efforts for some time in flood management for doing multi-benefits and flood systems. So some cases the bypass has been an emphasis to that, but we see that there's efforts even in res management. So right now, even SAFCA is seeking a grant with Cal Fish and Wildlife, for example, for salmon improvements to the temperature. So those are efforts we're seeing funding coming. That's Prop 68 funding. The other areas that we're seeing potential is it's been, to be honest, I thought there would probably be more emphasis on it, but, doing more groundwater recharge and SGMA-related grants and efforts. So we've seen that. But I think it's probably hasn't been robust funding yet coming on the state side. I think it's been more on the planning support side and some pilot efforts, so versus doing significant projects tied to that. So these are just some of the areas that we're seeing. We've kind of actually did a fairly lengthy kind of looking at both federal and state programs. Right now, the BRICS has been a program on the federal side that's afforded some opportunities for some projects. So these are just kind of the landscape. It's kind of evolving. We're still trying to see what's going to be done from the federal side with the Bureau, particularly with the money that came through the infrastructure bill. So we're kind of always at, how would I say, on the alert. Thanks.
Thank you. Any other questions or thoughts from anyone in the room on these two presentations? Back to you, Ron.
Let me just say that the region is rather blessed to have such talented folks who work on these issues, and often in quiet obscurity. So thank you.
Well, I would do a lot to my predecessor, Tim, here is in the audience. So,
Very nice. Thank you for that. Rob, go ahead and make sure that green light is on.
There we go. So my bottom line question is, how do you both see the Water Forum? What do you see as the role of the Water Forum in FERO, the future of FERO in this region?
Well, I kind of laid out the different components or opportunities. I think really what it comes down to is for any aspects of getting funding, particularly from the federal and state government, if you can't say you have a strong regional support for a project, you're not going to get funded. So I think it's got to translate into, fully supportable by essentially all parts of the community for its implementation. That's the key. Then we can kind of make the funding getting to Barbara's. We can start aligning initiatives for funding to the federal and state government.
And I'll just add that, these programs provide flexibility in the operations of Folsom and can provide opportunities to meeting the co-equal objectives of the Water Forum. And so I think it's definitely a supportive role. I don't know where it falls within the Water Forum, but these actions and programs will help improve management of the basin for many objectives.
Barbara?
So I would just encourage you as you start to develop the projects, which obviously are a ways away, to be very specific in your metrics of success for both objectives for the water forum so that you can get that support from our broad base. I think, often we hear flexibility, but what does that translate to for the environment or for public access or for, all the other kinds of things that we are looking at. So I would just like to encourage you to look for those partner agencies early to really develop a multi-benefit with environmental benefits as one of the main functions of the grant process. So thanks.
Thank you, Barbara. Anyone else online with questions or any thoughts? Go ahead, Leo.
Hi, Gary. So you mentioned a 5-year schedule, assuming you get a contract in place. So what happens at the end of this 5-year period? You have a report, you have a plan?
Yeah, so then what you do is we would take it to the federal government to make it actionable. So then the Corps of Engineers would go through an engineer's report and then take it into a water control manual update.
Okay, then my follow-up is, so once you've taken it to the Corps and start guessing, what kind of time schedule are we looking at then? I'm looking at the big, at the larger picture. Do we have to wait maybe a decade or 15 years or so before we have a program that's, I don't know, 50, 80% implemented, or what? What are we looking at?
Well, for the work with the Corps of Engineers, that would be fast-tracked. But to be quite honest, it's going to take that long to work it through that. I mean, all the things that have been described here, the constraints and management, just to work through it's going to take a long time.
It will. That's what I'm looking for. And just as an aside, part of the reason I bring it up is that I was looking at number one, at the grocery stores, and number two, at the Chinook salmon limits. There are no more Chinook salmon, essentially. Even in Alaska, though, their numbers have just plunged. So I think that the fish or our resources are on a different time track than our programmatic implementations. That's I guess the point I'm trying to bring up.
Yeah. So maybe to put a little bit of hope in all this is that in the Mendocino example, or the Corps does allow you to do deviations. So even before getting through the official process all the way that we're talking about, there's still opportunities to have a deviation where they can start practicing these things. So I think as we just get engaged here, I think those opportunities might come out, and that at least flexibility can be allowed.
Yeah.
We appreciate the hope, Gary.
Yeah.
Ashley, I think you have something. Why don't you come up here?
Yeah, just to kind of build on your question, Rob, in terms of specifically FERO and how that relates to the Water Forum and Water Forum 2.0 going forward. I think there's a lot of value in there is a lot of value in these presentations today, and in my mind, it's twofold. So understanding the status of these programs and the goals and what's been done and what is upcoming is helpful for us all. And I'm thinking specifically of the Flows and Operations Working Group that we have going on right now. So beyond just specifically what the Water Forum's role is in FERO, I think for us all to be grounded in the system that we are working within, and what like I said, what is planned, what's been done, so that we can have meaningful conversations around not just FERO, but how the FMS can be updated, how it can be cemented into the new Water Forum agreement. Add that.
And that's really helpful, Ashley. Thank you for making those connections. And then just to note that our presenters and our moderator, all of our presenters are on our Flows and Ops working group. Thank you so much for all of the time you put into this today and for being here. So a round of applause for our panelists. All right. We do have a break, and we're exactly on time, actually. So we're going to take a 15-minute break, and then I'll check in with Ann. I'll check in with you, our moderator for our next panel, and we'll get going right at 10:25. Thank you. Okay, thank you very much. Excellent. I'm going to just go ahead and turn this right over to Ann Sanger, who is the moderator for our cold water management panel, to frame this up and introduce our presenters. Thank you, Ann.
Now it's on. Okay. Thank you, Tanya. So it's great to see everyone. Welcome. This is an issue near and dear to my heart, so I'm so glad we're spending some time focusing on it. I'm going to look at my notes just quickly. Years ago, when I started working on American River things, someone said, you know, there's 3 critical issues on the river, and they are temperature, temperature, temperature. So I think that's still true today. So it definitely merits our attention. At the April plenary, we did some brainstorming, and there were 14 different ideas for adaptation strategies and solutions around cold water management. So I think we're going to hear about some of those today from our subject matter experts. And I will just let you know the order of things. It's on your agenda, but first, we're going to hear from Erica Bishop about the context of the issue and to define the problem. We're going to hear from Craig Adley about cooler Folsom inflows. So basically, we're going above the reservoir, in the reservoir, and then below the reservoir. Then we're going to hear from Chris Hammersmark about cooler Folsom outflows. And then from Tom Goring about cooler Nimbus outflows. We're going to do about 15 minutes of Q&A, which I think will be very interesting. And I know a lot of these issues we've talked about, but I think Water Forum, I feel like we were predicated around the cold water issue from day one. And I just, not that we've gotten away from it, but it's an intractable issue in some ways, and it's going to get even harder. So I think today's session is so important. All right, with that, Tamika did a beautiful job of introducing everyone. I'm going to shamelessly ask everyone to do self-introductions, not to take away from their gravitas, but if you could just say who you are, what your position is, and maybe a little bit about your connection to the Water Forum, that would be great. And starting off with Erica.
Thanks, Ann. So Erica Bishop, most of you know me, but for those of you who I have not had a chance to meet in person yet, I am the Water Forum's program manager. I oversee our habitat and science work on the river.
Craig Adley, I'm with Stan Tech. I'm a long-term consultant with PCWA working on the American River Watershed.
Hi, Chris Hammersmark. I'm a consultant with CBEC Eco-Engineering, and I've been working with the Water Forum on temperature-related issues since 2009.
I'm Tom Goring. I also work for CBEC Eco-Engineering part-time, and some time ago I was on the staff of the Water Forum.
Great. Thank you, everyone. All right. So with that, we're going to do the context setting and defining the problem with Erica.
Okay. So thank you all for being here today. I'm excited to talk with you about our temperature and fisheries context. Is it loud enough? I need to yell. I'm used to doing that on habitat tours over the sound of equipment. So talk a little bit of our temperature and fisheries context and frame up the issue in light of some of the solutions our other panelists are going to be talking about. And there it is. All right. So quickly, looking at salmonids in the American River, there are so many species that call our corridor home. However, for the purposes of this conversation and cold water management, we are focused just on fall-run Chinook salmon and our steelhead trout. Our steelhead are federally listed as threatened, and they are of fairly low abundance in the river. They do not do terribly well under current conditions. And our fall-run Chinook salmon are much more abundant. However, as we all know, their population is in peril, and the fishery was closed this year. Multiple years of drought have really, hit our fish very hard. And The differences between Chinook and steelhead are numerous, and that's an entire presentation in itself. We can't really get into that today, but do know that our spawning and both species use our river for spawning and rearing. And more specifically, regarding cold water management, we'll be talking a lot about the fall run Chinook adult spawners and our steelhead trout juveniles, because they are the most sensitive to our temperature changes in the river. And depending on the biologist that you talk to, there's a lot of information out there that supports that we used to have multiple salmonid runs in the river. We expect that, there's good evidence that we definitely had a spring run and potentially even a fall run. And that is relevant because Pacific salmonids in the form that we know them now have been around for about 5 million years. And if you think about the last 200 years in the context of 5 million, it's the blink of an eye. But in that blink, we have drastically altered the extent and the quality of the habitat available to our salmon and steelhead. What you see here is a map. Many of you have seen this before, but look at the red lines. This is the possible historic extent of habitats available to our fish. This was over 200 miles of main stem and tributary that they would have been able to potentially access in the past. And we came, as soon as Europeans came in, we altered their habitats and really made a huge impact in the mid-50s when we built Folsom and Nimbus, which serve our needs, however, have not done terribly much at all for the fish. And with the closure of the river when the last concrete was placed there, we almost immediately extirpated the spring run, which would have traditionally used those higher parts of the watershed for their spawning and rearing. And our steelhead would have also gone much farther upstream than they do now. The fall run always utilized the lower elevations of the watershed. However, they were not limited nearly as much as they are now, which is about 10% of our historic habitat is actually available to the fish. And that is the 23 miles below Nimbus Dam to the confluence. And of that 23 miles, really only about the upper 10 or 12 are suitable hydraulic conditions for spawning, and also, current conditions and with some alterations, the rest of the extent of the river is potentially viable for rearing, and we're still learning a lot about that. This slide, this has been around a long time. I wouldn't worry too much about exactly what's happening in a certain week along the year. I hope you can see this okay. It's kind of blown out. But the real take home here is looking at the seasonal distribution of our fish in the river. You see shading from light to dark to light again. And all this shows us is the seasonal concentrations of various life stages of our two target species in the river, and when they are most dominant versus when they're tapering off. And this is overlain with, actually hard to see over there, with our typical period of concern, and that is covering our summer and fall months. That is the time of year where we are most worried about suitable and optimal temperatures in the river. And when we, Water Forum and Reclamation and everyone is coming together to think about how we can manage temperatures actively with infrastructure and operational solutions. We definitely want our habitat to be good for the fish the rest of the time. However, except in the most extreme years like 2014, 2015, when the river was warm and very low in January. In general, we're able to have suitable or optimal conditions for temperature for life stages that are present in the river the rest of the year. So we're really focusing on that summer and fall time period for the purposes of this panel. So thinking about those life stages, actually I want to jump back a little bit. And note here again that fall run, adult spawning time period, and they are at their heaviest concentration in the late fall, and that is within this period of concern. And one difference between our fall run and others is that the fall run mature very quickly, and they do that on their journey back from the ocean. While they're headed back, they are absorbing their fat and muscles and actually they're giving everything they have, literally parts of themselves, to produce their eggs and milk, so that by the time they get back here to the Lower American to spawn, they are ready or very nearly ready to do so. So we are looking to, we want to avoid conditions where we're asking those fish to hang out for a long time when they're ready to spawn and complete their life cycle in warm water. When that happens, we can have what's known as pre-spawn mortality. That is something that happens even under the best conditions, but it is particularly prevalent in the Lower American because of when the fish are coming back, and it is generally so hot. One other difference between these two life histories and species is that our steelhead juveniles could be in the river all year. Steelhead do not necessarily outmigrate the first year after they hatch out of gravel. They may stay for a while and head out another year. So we're looking at that, that life stage has the potential to be there all the time. All right. So moving on to some temperature effects on these critical life stages. Looking at the steelhead trout, we're focused again on our juvenile life stage. And I wouldn't get too hung up on sub-degree differences. There are some variations here depending on the system and different peer-reviewed literature. But what you see here is a spectrum of temperature that our steelhead might experience and effects that we might see. And you can see the real take-home here is if you start there at the top of the list, 61 degrees, you have maximum fantastic juvenile growth could be occurring. And if you move up just a few degrees to 68, you're going from fantastic conditions to having fish that are starting to get stressed out. They may not be as effective at finding food. They could be more susceptible to disease. And that's such a small degree difference that we wouldn't even notice that if we stuck our hand in 61 degree water versus 68. But for our fish, every degree counts. And only a few degrees above that, you're getting into potentially aggressive behavior. They're competing for resources. And there's really, only about a 15 degree difference between fantastic conditions and potentially lethal conditions. So managing temperature for this life stage is very important. And looking ahead to our fall run Chinook, that's our spawning life stage. They are triggered generally to start spawning around 60 degrees. However, if we can get temperatures a few degrees colder, it's better for them and we have lower egg mortality. And there's a 70 degree listed there on the bottom bullet. And I have that included because if you think about it, our fish are not only living here in the Lower American, our juveniles pass out through the system on their way out to the ocean, and our adults come back in the same way. So they're passing through streams that end up, much warmer than ours, and they have a long way to go, and we even see that temperature sometimes on our own river. So to orient ourselves quickly, as Ann mentioned, Craig, Chris, and Tom are going to talk more about the upper watershed, but note the Hazel Avenue and Watt Avenue spots here. And the Watt Avenue is Reclamation's regulatory temperature compliance point. That is the spot on the river where temperature is measured and they are expected and try to manage to a certain temperature during a certain time of year to support critical life stages that we've been talking about. During dry and critical years and extreme conditions, they may be allowed to move that compliance point up to Hazel Avenue. But as you can see, Hazel is quite far up the river. And Rio Vista is there for context. We'll talk a little bit more about that in a second. Okay, hopefully you can see this. The gray line's a little difficult to see, but just orient ourselves to this thermograph. What you see is 4 years of data, starting with the beginning of calendar year 2019 through the end of 2022. And note across the top right, you see a blue line for Watt Avenue, a green line for Hazel, and those are our two temperature compliance points that are very important on the river. And we have Rio Vista in the background in gray. And note that the annual pattern of temperature changes over the year is fairly, is pretty much the same. You have cooler temperatures in the winter, they creep up over the spring, you have peaks in the summer and early fall, and then the temperatures go back down. And this is the same over the years. However, notice that the peak of those temperatures is very different between these 4 years. So this data includes 2019, which was classified as a wet year on the Sac Valley Index, and then it's followed by 3 years that were dry or critical. And let's take one life stage to look at. Our upper optimal steelhead rearing. That's that 65 degree line that you see here on, is that, oh, I just touched that. Yeah, that's the red line there, sorry, the top red line that you see there. So looking at that upper optimal steelhead rearing line, yes, thank you, Ashley. So you see where that occurs, and that line continues across the page. So look at 2019, and we see that during a wet year, using the infrastructure and operational tools that we have in place right now, which mostly include the temperature control device at Folsom that you're going to hear a lot more about from other panelists. Reclamation is able to manage the river using the shutters on the TCD and meet, pretty much keep the river from, at or below that temperature that it's supportive, of the upper optimal range for that life stage in the river. However, look at years following that in dry and critical years where it becomes more difficult to manage for that over summer steelhead temperature using the infrastructure that we have. And we regularly exceed those temperatures for extended periods, and it was quite bad in 2021. And so that is our critical steelhead rearing life stage that we are managing for over summer because they may stay in the river year-round. One other key point to look at here is our pink or purple line, depending on how you classify it, and that is at 60 degrees. And that is our Chinook spawning trigger temperature. And I have included that because that is also something else that's managed for over those spring and fall months. So Chris in the past and now currently Craig and his team are working with Waterforum and Reclamation and others to look at the temperature profile and think about how much cold water we're going to have over the year. That starts in the spring, and as we get closer through the summer and looking into the fall, they are looking at how we can manipulate the system to help bring down temperatures to around that 60-degree mark on or about November 1st. So it's a delicate dance all year long between storage and temperature, not letting out too much water, making sure we balance that with deliveries, because we want to make sure that we can get down to that November 1st 60-degree mark as quickly as possible, because that is our triggering temperature for our fall run Chinook coming in. And we don't want to be spending too much time in the warm water. That November 1st period hits the most common, the heaviest spawning that we have of our fall run. And you can see one difference to take home from this thermograph is in that 2019 year, there's a kind of a zigzag progression as the temperature moves down over the fall. And that is because of the way the shutters and are operated on the TCD, which you'll hear more about. But in other years, Reclamation is realizing that with the cold water pool we have available, we're not going to get there in time. So they will run something called a power bypass. And that is where they are able to bypass making power so that they can access water that occurs in the reservoir below the area where the TCD can reach. And that is the coldest water that we can get, and they will pull some of that water in to help bring that temperature down as quickly as possible and try to get to that November 1st target. And you can see the difference there that occurred in the last 3 years that power bypass was necessary. But Chris is going to talk a lot more about that. And one last thing is that looking at that Rio Vista line, that gray line in the back, we are over that 70 degrees pretty often, and that is known by many biologists. It's considered that it might be a barrier for a Chinook. We're not certain exactly what the effects of needing to, pass through and butt up against those temperatures are, but we know that it isn't good, and those temperatures, those higher ranges do occur along the route that our fish need to take. And in a year like 2021, you're seeing that we actually have sustained periods of those high temperatures in the American River where the fish are, needing to spend a lot of time. And the one other thing, we are going to talk a lot about cold water management, the TCD, the power bypass, and operations that, actions we can take here in the watershed. But the operations of Folsom, because of where we are in the system, we are part of the Central Valley Project, and there are a lot of out-of-basin needs, as we all know, that affect the way we operate the reservoir, and that is something that did happen in 2022. Although our watershed was in better shape, it wasn't necessarily in a critical hydrologic condition. It was kind of operated as such because we needed to make trade-offs in system-wide operations to protect other fisheries that might be in a more critical condition than ours. And we are closest to the Delta, so Folsom gets hit hard for making deliveries and managing Delta outflow when we're in a pinch. Ashley, can you? Yeah, it doesn't want to move. Okay, so you've heard a little bit about critical life stages and temperatures that our fish might be experiencing even just the last couple of years. And to bring it forward, looking to the future and solutions, I want to touch back on some of the results of the ad hoc tech team that many of you were involved in. Take home there is that Folsom storage is expected to be critically low more often. Our end of May storage, which is a massive indicator of what we're going to have to work with for the managing summer and fall temperatures, is also expected to be lower. And as you can expect, the effects on the fishery regarding higher temperatures and longer durations of higher temperatures are potentially lethal in the watershed. Last but not least, we hear a lot that, it's all about the fish. We have other resources and values on the parkway that we want to focus on. And absolutely, this panel is mostly about the fish because that is what we're really affecting with our cold water management actions. However, when we are able to manage for suitable or optimal conditions for our fish, we're generally protecting and serving other resources and values, not only the co-equal objectives, but our quality of life on the parkway. And vice versa. So I'm going to use summer of 2021 as an example. Summer of 2021 on the river, we were down near rock bottom, almost down to 500 CFS, which we can't really go lower on the river. The river was warm. I think we got up to 75 degrees for like an extended period. We were out doing construction and I couldn't believe what the river looked like. So the conditions were not good for fish that summer and fall, but also they weren't good for recreation. They affected the operations of our vendors on the river. They have to move their takeout locations. People aren't as interested in coming out to the river at all. And really up even out of the river, up at Folsom Lake, it's not as nice to have a picnic with your family 75 feet below the bathtub ring, right? Sitting in the dust. It's harder to deal with your boat. It just is not good for that resource either. We do have public health and safety concerns when the river is low and slow like that and warm. There are more drownings and accidents reported actually during low flows than during flood conditions by SAC Metro and regional parks. And we also see when the river is slow and warm and overabundance of algae, the clarity of the Lower American is very important. It's really an amenity that we all enjoy. And when it's warm, algae goes crazy. The water column can be completely filled with it. Summer of 2021, it looked like pea soup. And that can be detrimental to not only water quality, but, humans and also pets that may be swimming in the river. And that affects our aesthetics, right? The river does not look good. The corridor is not as nice to be in. And our other species are affected by low water conditions. Other fish, amphibians, other wildlife, their access to prey may be reduced. It's dry. It is just not good for any of those other species. And our vegetation, especially riparian, can suffer when it isn't having the inundation that it needs. And on the infrastructure side, we know there are effects to M&I intakes when Folsom gets too low and when the river is low. It costs more to treat the water when it has a bunch of algae and organics in it. So that affects, even some of our water forum member purveyors here. And the maintenance associated with those types of conditions in the river. When intakes get full of algae, it's a massive expense to get the system cleaned out and get it back up and running. So although we are all about the fish today, I would just encourage you to remember that when we're able to provide those suitable conditions for the fish, it's generally pretty decent for other resources on the parkway too.
Great, thank
you. How we doing time-wise?
Sorry about that.
A little bit over. We're good on time.
Okay. I'll make up for it. We'll have enough time for Tom to talk at the end. I'll just give a little bit of watershed context related to inflows to Folsom that might be able to help us control temperatures, and then a few methods to control temperatures in the Lower American River based on inflow. Watershed, you've seen it many times. It's a kind of a unique watershed, triangle watershed with one leg back there against the Sierras and Tahoe, and the point being Folsom Reservoir and the Lower American River. This is the same watershed. The point of this is, if you look on the right side, there's reservoirs in the upper watershed. Loon Lake, Union Valley, Ice House, French Meadows, Hellhole reservoirs. And I'll show you a slide or two about the storage that's available in the upper watershed. I'm going to break the flows up into 4 parts: the South Fork American, the Middle Fork American, the North Fork American. Those two come together into the North Fork American arm of Folsom Reservoir. And then the Newcastle Powerhouse, which is water that comes from PG&E's Drum Spalding project from the upper Yuba River system. And there's some outflows, and I won't talk much about those. So this is the South Fork inflows from 2000 to, I think, 2022, 23. The left axis is a log scale, so you have to pay attention to that. On the bottom is the years. And if you look at that, there's relatively consistent flows, about 1,000 CFS. On average, it's 1,300 CFS, about 900,000 acre feet that come in from the South Fork. A lot of that is controlled storage releases in the summer. This is the Middle Fork American. If you'll notice, the orange is a little above that. The Middle Fork American has a little bit less storage, and they peak at about 1,000 CFS into Folsom Reservoir, whereas the South Fork American peaks at about 2,000 CFS during the summer. Now I'm going to overlay the North Fork, which is a natural hydrograph that comes in, and you'll see that that's quite a bit different hydrology, because in the summer it's really low. Those low discharges are the summer flows, and then there's winter and spring high flows that come in. But you'll notice that the South Fork and Middle Fork are consistent all through that time period during the summer, when low flows or natural low flows would be in the system. The Middle Fork and the South Fork are releasing storage water into Folsom Reservoir. And then there's another inflow, that Newcastle Powerhouse from PG&E. It's relatively significant. It's about 70,000 acre feet, about 300 CFS. Comes in the early winter and winter time period, and then in the late spring it reduces as they're filling reservoirs up in the upper Yuba system. So those are the 4 inflows into Folsom. This is a picture of the South Fork and the storage. So Ice House Reservoir, 45,000 acre feet, Union Valley 277, Loon Lake 76,000. Overall, there's 400,000 acre feet of storage in the South Fork American. Before I leave that, let's pay attention that those red arrows are tunnels, and all that water comes through tunnels, from reservoir releases through tunnels, all the way down to Chili Bar, down here on the left, upstream of Folsom Reservoir. So that water that comes from those reservoirs is cold water and doesn't warm as it goes through the tunnels. The same thing happens in the Middle Fork. French Meadows, 135,000 acre feet. Hellhole, 207,000 acre feet. In total, here on the left, it's 340,000 acre feet. Combined with the Middle Fork, or the South Fork, there's 740,000 acre feet of storage. About 76% of the storage that we have in Folsom, which is almost 1 million acre feet. So it's a significant amount of storage. Again, there's red arrows, shows tunnels. The water comes from low-level outlets from the reservoirs through tunnels, comes down to Ralston Afterbay. I doubt this works, the pointer, but Ralston Afterbay, the water comes in. This is summer temperatures that are shown. It comes in there at about between 50 and 55 degrees, and then goes 20 miles downstream to Folsom. It warms about 10 degrees, comes into Folsom about 65 degrees. The South Fork comes into Folsom at about 60 degrees because it's higher flows and it's a shorter distance. And so when it gets into Folsom, it's a little cooler. We have good temperature models for all the system, which is a blessing in terms of being able to understand how to work with temperature in the system. And this is just an example of inflow regressions for the Middle Fork on the top is a graph, the South Fork in the middle of the graph, and then this bottom one is just an August temperature in the South Fork, and it has flow on the bottom axis and temperature on the left axis. And the higher the flows coming into Folsom, the colder the temperature. So that shows when there's high flows, it's about 60 degrees in the summer. And then in 2001, when there were very low flows being released from the South Fork, it was up to 70 degrees inflow into Folsom. The key things are the amount of inflow and the time of year the inflow comes into Folsom Reservoir. That's what controls the temperature. And so one of the ways that we can modify temperature in the Lower American River is in the water forum agreement. There are water forum mitigation flows in dry years. It's water that is released from storage, upstream storage, PCWA storage. It wouldn't be released in those years other than that it is mitigation water. And the left graph shows how it can modify temperatures inflows into Folsom. So it's like 12,000 acre-feet over 3 months, or 20,000 acre-feet over 3 months, or 35,000 acre-feet over 3 months. So that cyan line shows that you get about 4 degrees Fahrenheit temperature change on the inflows into Folsom, and that translates, depending on the right, the black line is the baseline, translates into about a degree Fahrenheit decrease in temperature in the Lower American River, depending on how that water comes in, the timing, et cetera. So that a degree is significant. The reason that happens is because this is just, I think, August. Are these plots. Left is without the water forum mitigation, right is with the water forum mitigation. Top plots are just showing temperature, the warmer epilimnion, the cool metalimnion, the yellow, green, and then the cold hypolimnion. And you can't see too much. There's some shutters, the Folsom shutters shown. Can't see too much difference in those top two plots. Right is when there's 35,000 acre-feet coming into the reservoir. But if you look at the age of the water on the bottom, you can see that green band of interflow through the reservoir, that water comes in and flows across the metalimnion to the shutters and is used by the shutters to decrease the draw on cold water pool. And if you look at the right one, that band's a lot bigger. So putting that cold water in during the summer helps with temperature management in the Lower American River. That's one mechanism. The other mechanism is the amount of flow that is in the Lower American River. So this is just a plot. Bottom axis is the river miles, Folsom release on the left at about river mile 28, 29, temperature on the left axis. And then Watt Avenue, that was just mentioned, is about river mile 10. And if you release at 64 degrees from Folsom at 3,000 CFS, there's only about 4 degrees increase down the river. If you release at 2,500 CFS, there's a little over 4 degrees increase in temperature. But if you release a low flow, let's say 1,000 or a 500, there's like a 10 CFS or a 10 degree increase in temperature. So the amount of water that's released in the Lower American River affects water temperature. And somebody hit me? Good. So, and the amount of storage in the reservoir, so you can modify the storage in the reservoir to some extent. This is 2011, a wet year to 2016, has some of the worst drought years, 14 and 15 in there. The gray line is storage in Folsom Reservoir. It's on the right axis. So in 2011, storage was completely full, and water temperature, which is the solid line, the dark line, was less than 65 degrees in the lower American River at Watt Avenue. Then if you look at storage decreased over those years and look how temperature increased inversely. So by the time you get to 2015, water temperatures in the lower American River are over 70 degrees, and storage was only about 500,000 acre feet. So storage is a huge driver. It's the cold water in that storage, and Chris will talk a little bit about that cold water. It's also the inflow that comes in. And like I said, we could modify a degree or two on top of this, but that's the main driver. Like the water form mitigation flows could decrease that 73 degrees by a degree or two, but the main driver is that storage in the reservoir. This is just another example of the storage relationship versus temperature at Watt Avenue. This is in July. Storage in July, high storage, we get 64 degrees. Low storage in July, we get 72 degrees in the lower American River. So potential methods to reduce water temperature, modify inflow and outflow. So there's the water forum, dry year mitigation water, 10 to 47,000 acre feet. It can have a benefit without question. For a month or 2 or 3 months, it can decrease temperature by a degree for certain. There's some other options. You could reoperate the reservoirs upstream, get the cold water into the reservoir, into Folsom sooner, take advantage of that cold water. The only way you could do that, though, is to release that water from SMUD or PCWA. They store that water and use it for power generation during the summer primarily, when power prices are high and power demand's high. And so the cost to put that water into Folsom early would be the cost of the power. So if you put 30,000 acre feet in just for cold water, it would cost you whatever that power is. Sometimes we do transfers, and you can transfer water in drier years. Again, that's like the water for mitigation water. And then you can modify Folsom storage. So to modify operations, the amount, the timing of outflows. That's one of the things that the flow management standard, water forum flow management standard intends to do and does, is help maintain good flows in the lower American River. Other than that, you could purchase water. So those are options for inflow into Folsom and managing cold water temperatures.
Great. Thank you, Craig. Yeah, let's switch over to Hammer.
So this is a year in the life of Folsom Reservoir, with the vertical axis being the volume of water and the colors showing the volume of water that's different temperatures. And when we talk about cold water pool, we're really talking about the bluer shades that we can see early in the season dominate the reservoir before it has stratified. But then as the season progresses, solar radiation warms the surface, and that cold water pool is actually pretty limited. And so we may have a lot of water in the reservoir, but not a lot of cold water. And how we manage that cold water and release it is really what I'll be talking about. So this is an upstream view of Folsom Dam during a drought. The 3 vertical structures on the right side beneath the crane, those are the temperature control devices, or TCDs. And to the left, you can see the primary radial spillway gates. Here's a schematic of the same thing. On the left side is a cross-section of Folsom Dam showing the spillway gates at the top, and then all the way down to the lower river outlets, which is the lowest elevation that we can use to access cold water in Folsom Dam, or Folsom Reservoir. And on the right is a schematic of the temperature control devices. They consist of 3 gangs of shutters that can be pulled to, or inserted or pulled to control what elevation water is pulled from the reservoir, such that we're trying to only pull as cold of water as we need at any given moment, saving the other cold water for later. And so on the left side, you can see the first one has all the shutters in place, and then if colder water were desired, then a set of shutters would be pulled, accessing lower in the water and lower in the temperature, lower in the profile, and lower temperature as well. They really aren't as solid. Well, no, they're plenty solid. They're sieves, they're not straws. There's a lot of leakage that occurs through this. It's both through the superstructure as well as through gaps in panels. The picture on the left was taken with a robotic vehicle where two shutters have not correctly butted up against each other. It's pretty common for debris to get in the way and to leave a gap that allows for colder water to make its way into the TCD than what we're actually targeting. On the right side, you can see the superstructure, and there are all sorts of gaps where water also can come in. And so while we say we're drawing from a certain elevation, we're drawing a majority from that elevation, but then there's a fair amount of water that's getting pulled in from the superstructure as we go down in elevation. Some of the work that Craig's team has done building the CE qual model for Folsom has identified that on average, we're looking at about 35% leakage. Now that changes with reservoir stage. The higher the reservoir is and the more water has an opportunity to go through the TCD, then you have higher amounts of leakage. And then once all the shutters have been pulled, then you're not really having any leakage because you're drawing directly from your penstock elevation. But leakage is a big deal. I won't say that when the cold water is released that it's a waste, but it certainly could be used in a more biologically beneficial way later in the season if we were able to keep it stored. So what are some of the issues with the current TCD? First, it's not automated. It's fairly clunky as far as making adjustments. It requires a crew of at least 4 to go out there and operate the gantry crane, hook up cables, and actually lift these metal shutters. For each one of the 3 TCDs, there's one for each powerhouse. Each of them is composed of several panels, and so when we say pull a shutter, we're actually pulling several shutters, and it takes 2 days for them to go through a shutter pull operation, and it typically takes at least 5 days to get it scheduled. So it's not anything that can be like nimble. You know, like, oh, we need to pull a shutter. Talk to you next week is kind of how the current situation is. They're not easily adjustable as far as trying to withdraw from different elevations. In some of the drought years previously, we actually broke up some of the shutter gangs so that we had a little more incremental control over where we were pulling water from. That did provide a temperature benefit, but Reclamation is very wary to do that because every time they break the shutters apart, they're worried they're not going to get them back together and they're going to lose control of the whole device. So it's not something that they do readily. I touched on the leakage aspect. They are leaky. It is significant. It's definitely something that needs to be talked about. And the last thing is the way the TCDs are currently configured, they don't allow access to all of the cold water that's in Folsom Reservoir. So here on the left again is the cross section that we saw previously, and then on the right is a hypsometric curve, effectively the volume of water at various elevations. And the red line that I've provided there shows the center line of the penstocks, and we have approximately 50,000 acre feet of water that's below the penstocks that is the coldest water in the reservoir that we can't access unless we bypass the powerhouses. So to be able to release that water, we have to do what's known as a power bypass. That has a cost, and I'll talk about that again in a moment. So what are some of the things that could be done? The upper bullets talk about physical infrastructure things, and the bottom is more of a policy economic way. So what are some of the things that could be done? You could implement a cold water access conduit or an elephant's trunk. I'll show that in a moment. You could address the leakage. You could improve the shutters such that they're mechanized so that you could adjust them more easily, say with the push of a button instead of a phone call that then schedules a crew a week plus later. And you could do the mechanization such that you're able to target elevations more precisely than we currently do. Both leakage reduction and shutter mechanization and automation are part of an Army Corps of Engineers and SAFCA proposal to upgrade the shutters. I'll show a slide about that in a moment. Another topic that has been brought up is, could you actually plumb the lower river outlet to the powerhouse, either by creating a new penstock through the dam and connecting that to the existing powerhouses, or even building a smaller powerhouse that would just utilize the lower river outlets. So trying to think of ways where the loss of power wouldn't be the major obstacle to getting this colder water into the river. And then lastly, a sort of out-of-the-box solution that's been thrown around is, rather than trying to spin power off of this cold water, there is a significant loss in power revenue, the generation. We could establish a fund, an endowment that would basically take care of that lost power revenue. We would know that it is there, and it would still get us all of the same temperature benefits. Tom and I participated in a value planning exercise in 2014 that the reclamation convened. All of these topics were discussed. As far as the benefit cost ratio of all of them, the Power Bypass Monetary Fund was by far the best selection. It didn't get a lot of traction. Leo, just in talking yesterday and reviewing this presentation, said, well, gosh, even if that's not a long-term solution, that should very much be a short-term solution while we're working the other pieces out. And so I think that's something that people definitely need to be thinking about more. Quick, poor schematic of what an elephant's trunk might look like. You know, there's different engineers come up with different solutions, but the idea is a siphon or plumbing that would effectively draw water from tens of feet farther down than it currently does, so that water could run through the penstock. It would allow us to access the water without needing a power bypass. It's not currently a part of the Army Corps SAFCA PCD upgrade. I'll talk about that again in a second. Back when we were discussing this, Reclamation did provide a feasibility study on an elephant's trunk. They found it to be infeasible. Those of us who reviewed it had some questions about some of the assumptions that they made. I think it's definitely something that should be revisited. I personally am not ready to take it's infeasible and walk away from it at this point. This is a schematic of what we currently know about the Army Corps SAFCA TCD upgrade project. It was authorized as part of the dam raise that Gary talked about previously. Effectively, what it would do would make the whole system, one, automated, so that it would be the push of a button rather than a phone call and scheduling 7 days later to make any given change. It would allow us to withdraw almost infinitely from the reservoir at any elevation we wanted, trying to target precisely the temperatures that we needed to achieve downstream temperature targets. When this was first brought to us in 2014, the leakage issue was not at the forefront of the Corps' designers' minds. We educated them as to that issue, and so that has now been something that they are working into the design to address. And previously, about a year ago, there was a debate. There's always a limited funding, and there was a debate on how many units would be upgraded. The costs, as all these projects go, the costs were higher than what they were initially expected to be, and so they asked us, can we get away with just upgrading one? Can we get away with upgrading two? Do we have to upgrade all three? There was a lot of pushback from Reclamation on upgrading just one, because they said, well, we have a unit go out every year, either on purpose or not on purpose. You're really handcuffing us here if it's only one unit that can do that. So then we sort of inched them towards two. At this point, my understanding is that funding has been found for all three, and so that's the current plan, is that they'll be upgrading all three of the TCDs. what else might be done? On the top, I just talked quickly about a modeling study that was done in 2007, where they looked at base load versus peak load. So I'm sure you're all aware, but Folsom releases water, and then Lake Natoma is the after bay. And for Folsom, their peak loading. So for say 4 hours, they will release 8,000 CFS, and then for the other 20 hours, they'll release 200 CFS. They're taking advantage of high power demand and higher power prices. And then Lake Natoma's elevation fluctuates, but we just see a straight 2,000 CFS, say, from the Lower American. Well, there was a modeling study that was conducted to say, well, what if we just ran Folsom like we run Nimbus? We're releasing 2,000 CFS all day instead of 8,000 and 200. And what they found is that actually resulted in warmer temperatures downstream, that kind of constant flow work to destratify the reservoir. It wasn't able to sort of stratify again during the lower flow conditions. And so that modeling study indicated that wouldn't be something we would want to do for improved temperatures. Separate from that study, operationally, the flow management standard has a lot of important elements that will affect temperature as it releases Folsom and eventually makes it to the Lower American River. We know through years of work and modeling, a lot of it done by myself, that changing the magnitude and timing of releases from Folsom can have very dramatic effects on downstream water temperature. If we release water in a more thoughtful way with regards to temperature, it can be cooler. I'm not saying that there aren't other demands that want the water to be released the way it is, but there are opportunities there if there's other flexibility in the system. And then lastly, to touch on something that Craig showed pretty well in his final slides, having more water in the reservoir gives you more cold water to manage. And it really is as simple as that. And so the topic of carryover storage, which I know is being talked about a lot, is one way to allow us to release colder water from Folsom Reservoir.
Thanks, Chris. So you've noticed we're working our way down from upper watershed down to below, So I'm talking about the last chunk, which is Nimbus Dam, and I'll talk a little bit about even some options below Nimbus Dam. So Lake Natoma is, as Hammer just mentioned, is the after bay. And so if you're an operational geek, you think of Lake Natoma this way. There's Folsom on the right, Folsom Dam on the right, Nimbus Dam on the left, and in between is a little stretch of river on the far right, and then Lake Natoma in between. Many of us think of Lake Natoma this way, right? And how many people here have sent their kids to the aquatic camp? Okay, there you go. So I have always thought of Lake Natoma this way. It's a great big solar heater, and if you're trying to manage temperature for fish in the Lower American River, it just heats it up, right? How much does it heat it up? Well, here's 2 months out of last year, and you can see that the difference between temperature at the upper end of Lake Natoma and the lower end of Lake Natoma is 2 to 6 degrees difference. So we're gaining that much heat as we pass through Lake Natoma. Craig's figure showed how that changes with flow rate, right? Because if the flow is faster, you have a bigger chunk, harder to warm, and it spends less time there, less contact time to get warm. So this is the same report that Hammer mentioned, and it did look at changing power generation from peak loading to base load. I'm not going to read every one of these because I want to leave lots of time for Q&A. But in essence, that report looked at several options. Some of them, according to the modeling they did, had minimal or no positive effect on temperature across Lake Natoma. A couple of them did have the potential to reduce temperature on a maximum basis by about 2 degrees, on an average basis about half a degree, and those were altering the Nimbus Dam debris wall. It's a big hunk of concrete that keeps bad objects from going into the powerhouse at Nimbus. Altering that So that cold water, rather than coming up and over and mixing, could kind of go straight into the powerhouse. Their modeling says there's a potential benefit there. And the other is possibly putting something like, the TCD that Hammer mentioned at Folsom, building something like that at Nimbus. And the report went on to say, this is the start of a level. More study is probably needed, and it suggested that there are probably options there at the powerhouse and moving this sort of stratified cold water into the powerhouse that probably haven't been quite plumbed yet. Interesting that was in 2007, and to my knowledge, we haven't done much since then to look at Lake Natoma. I think it's kind of sat there. Why is that? I think one of the reasons is it really seems intractable, right? It's this big chunk of water. But people have brought up ideas that, to my knowledge, have not been studied. One is to run a pipeline, maybe run it down the bottom of Lake Natoma, and so you can kind of mainline the cold water from the penstocks at Folsom to the penstock at Nimbus, right? Maybe it's covered in installation, I don't know. Hasn't been studied. I'm not going to pre-guess whether that's a good idea or not. Folks have said, well, Lake Natoma gains 4 degrees and the Lower American, same length, gains 2 degrees. Well, what if we just get rid of Nimbus Dam? And instead of having an aquatic center, we just have a longer river, right? Well, okay, it might have a technical advantage. I think there's a social cost there. Recently, I heard someone say, let's cover Lake Natoma with solar panels, right? We know we need electricity for air conditioners. We need some solar power. If we covered it with solar panels, it would be shaded, right? I think it's a great idea. And here's mine. What if we build a giant stand-up paddleboard, big enough to cover the whole lake? Then everyone wants to sup now, right? Everybody can sup at one time on one. All right, and maybe there are some other ideas. I don't mean to make light. My point is that I think in this debate, particularly when this conversation meets some of our state and federal agencies, we tend to meet this great big head shake. It's like, no, that's not going to work. We looked at that in 2007. 2007 said you never get more than a half a degree. So let's just, we did that. And I think knowing the challenges that are coming with climate change, I think it's time to look at these things again and look at it with the frame of mind that every half of degree is probably going to be needed. So downstream of Nimbus Dam, again, some of these may have been studied in kind of an ad hoc way, but to my knowledge, there aren't any published studies. But here are some of the ideas that you could do: more shade, creating thermal refugia. I think in one of our whiteboard sessions, someone suggested the idea of something like a salmon highway, a corridor of just cold in the river, or in either through the whole river or parts of the river. We've looked at some of those things again in an ad hoc way before, and we know there are challenges. But for all of these, again, I think we've reached the point where they need a second look. One of the things on that list is injecting cold water, and I know some folks recently have said, what about all that aerojet water, right? It's cold. We know groundwater tends to be colder. It tends to be in this region about 62 degrees. So here's a very quick back of the envelope calculation. On the right-hand side, you see a table. I pulled this out of Aerojet's waste discharge permit. You can find everything online. And if all of them were running at maximum, you'd get about 70 cubic feet per second. They don't usually run at maximum. They don't even all run at the same time, but that's kind of a maximum limit. So here's a scenario. The Lower American's running at 800 cubic feet per second and at 68 degrees, and we get to inject that 70 CFS at 72 degrees. What kind of gain do you get? About a half a degree. That mean it's infeasible? No, not necessarily. Again, every half a degree, I think we need to be looking for. One of the things with the Aerojet stuff is I think some of this we're getting for free now, right? It's just happening. But we could look at, is there a way to do this in a more strategic way? Finally, recommendations. So, since I got to do the lower part of the river, I get not the last word because we're having Q&A, but I get to see if I can tie it up. I think it's time to look at some of these, maybe all of these options again. My limited experience from being involved in a value planning study that Hammer mentioned back in 2014 said that that's a really useful exercise. It's a place where you bring some knowledgeable people together. You do some technical analysis over, you know, a few day period. If we're going to look at the whole suite of things, I think we need like a week, maybe more. And I think we need to be thinking about an all of the above strategy from the top of the watershed, you know, all the way down to the confluence. And I think in essence, here you go, here's my list. That's not comprehensive, that's a sampling of everything you just heard from from me and the speakers before me. And I think we need to look at it all again. Look at it, and the value planning process would come out with a reconnaissance level estimate of a ranking of those alternatives, their constructability, their cost, and their benefit. And not their benefit like good or bad, but like how many degrees are we talking about? Talking about a half? Are we talking about 2 or 3? Part of the reason I feel strongly that we need to kind of look at it all at once is that over time, in the last, 16 years I've been involved in this watershed, we tend to look at it in pieces. And we tend to look at it a piece and say, wow, that one's really hard. And then we kind of forget about it for a while, like the 2007 study on Lake Natoma. It just kind of got set aside. And then we did look at some stuff in 2014. There's been limited progress. Virtually all of these options you see up there are additive. They're not mutually exclusive. You don't do something in the upper watershed and say, temperature's done. You don't do something at Nimbus Dam, one thing like shutters, and say, Folsom Dam, do the shutters, Folsom Dam's done. The benefits of many of these things add up. And so we need to be thinking about, again, an all of the above strategy. And I think given the recent history, last 10 years or so of the Water Forum and convincing reclamation to use a flow standard, right? I think we may have the potential for a Water Forum to push reclamation in the Army Corps to do some of these things as well. So, Anya, back to you. Ann, back to you.
Well, thank you, everyone. I know we are fortunate to have such wonderful, deep knowledge on our river when it comes to temperature and flow. So with that, we're going to go to some question and answer. Tanya, did you want to moderate? Or?
Yes, because I can see online. Thank you. That was really helpful. I like this temperature journey from the top of the watershed to the bottom and the framing of it. I think that was excellent. We do have some hands up in the room, and let's start here. Ron, we'll start with you. We'll go to Inga, and then we'll go to you. It's Tim. I didn't recognize you, Tim. Go ahead, Ron.
I'm sorry, this is Ron Stork. Do you have a sense on when the Corps' temperature control device will have final design and constructed? There's hope.
Not a clue. We should have asked Mr. Bardini from the last panel that question.
Good.
I've heard we still can.
We still can.
Yep. He just needs to find a microphone. And you can come up. Gary, why don't you just come up here? There's another microphone because there might be other questions.
Honorary panel member.
Yeah.
We don't have a chair for you, so you'll have to stand.
Okay, go ahead.
Yeah, so right now the design is at 35%, and I think Chris did a good job describing some of the deliberations on the design, getting to that point. It's now moving, just starting from 35 to 65. I think if I had to tell you, it's probably a couple years, you know, probably
To reach 100% design.
to get to final, and then
Tim, you're going to have to use that microphone or no one's going to hear you online, and turn it on.
Gary, I just wanted to ask, is the Corps inviting input from the expertise we have here? It seems like before we go too far with the design, it would be helpful for them to bring the experts to have a look.
Tim, you're fired.
No, you're not. No, in fact, that's the conversation we're having right now with the Corps. And right now we're trying to, to increase the facilitation between the Bureau and the Corps on it.
I'm going to ask everybody to scoot to your left a little bit so we can, on the panel, I need you to scooch to the left so we can see Gary. There you are. Yay. We got you. All right. You have a follow-up there, and then I want to go to Inga.
It's a second question, but probably to Tom. The Central Valley Project Improvement Act does tend to focus reclamations, or theoretically focuses reclamation's attention on Chinook salmon, steelhead trout. And I'm curious, and so that's natural reproduction of those fisheries. And we have another part of the fishery production world on the American River, and that's the Nimbus hatchery. Hatchery production, of course, is controversial. The question is how much competition with natural spawners and kind of natural life history created fish versus artificial fish. But nevertheless, we have that there. And the hatchery also suffers from temperature disease issues, and sometimes really quite serious ones associated with warm temperatures. So I don't think it's beyond our world to also focus attention on cold water management at the hatchery. And if there's anybody you can amplify or give us a little further discussion on what problems there have been and what opportunities there might be and what studies have been in the past.
I don't have much to add to that. I will add that virtually everything we talked about here in terms of improving temperature in the lower American River would have a hatchery benefit too. The hatchery has additional tools like putting a chiller in. But as far as state of the hatchery, you know, it's never been my wheelhouse, and anybody else on the panel? Can we flag that as something that's probably in Erica's working group?
Yes, we will be addressing hatchery. We'll be talking about how we might engage with the hatchery question in the corridor health group, what that advocacy might look like. There are various avenues we may take. One thing, the hatchery operations are a bit of a mystery, and we are getting better on our coordination with CDFW regarding monitoring on the river. We're having some good success with our crews working with theirs and sharing data, but the actual hatchery itself is, you know, it's a bit of a black box, and they aren't necessarily wanting to share a lot of information. So we get little snippets here and there. The hatchery is doing some genetic studies on their populations, on their produced populations. We don't know what the results of those are, but we know that they are looking at genetics. And then, Ron, you asked about natural production versus the hatchery. And I don't have the number right here at my fingertips, but part of the science and monitoring work that we're doing right now under our Fish and Wildlife Service grant is actually looking at genetics of our spawners on the river. And we are seeing that our natural population is just, you know, there's a heavy competition from the hatchery fish coming in. And it's difficult to tell exactly how much that is because our hatchery fish, only 25% of the Chinook are fin clipped. So we may not know, you know, just looking at them, you can't necessarily tell if it's a hatchery fish. You could be part of the other 75% that aren't clipped and still be a hatchery fish using the habitat. But I can that could get some of those initial results to you regarding like what that percentage is as far as fish using the in-river spawning habitat of the hatchery versus naturally occurring population.
I'm just suggesting that that's a legitimate point of discussion for the Water Forum 2.0, as well as just the ongoing work of the Water Forum. We don't necessarily solve everything in 1.0 or 2.0. The Water Forum works continuously over many years to try to deal with issues of interest and concern.
Thank you, Ron. Inga, you had your hand up. Then I'm going to go to Jim Ray, who's been waiting patiently online, and then I'll come back to the room. I see Leo and Tim would like to get in the queue. Inga?
Tom, I just wanted to ask you, in terms of the all of the above strategy, having a collaborative ranking, do you think there'd be money in the infrastructure bill from Congress to try to put something like that together?
I don't know. Who in the room has been successful getting money out of Congress? Well, it comes back to Mr. Bardini. Inga, I'm not sure if you mean money to do that process, or money to implement the things that come out of it. Either, yeah. I'm feeling pretty out of the loop on how to do that. I got to believe it's something we can push for.
Actually, the question is, I don't know right now. The Bureau's budget's been increased to handle some of these issues, and I'm just not sure how that's translating into implementation.
Mm-hmm.
Something we're looking for.
Thank you. Jim Ray?
Yeah, I was interested if anybody knows whether any of these creative and interesting ideas have effect on water supply reliability, either beneficial or negatively impacting.
I think in large measure, the things that we're talking about do not have an impact on water supply. We're using the existing water supply more effectively for cold water, but probably the biggest place where it might have an impact is reclamation's operations at Folsom. So, you have storage and they're releasing a large amount of water for Delta water quality and for water supply downstream. So that's probably the biggest driver in terms of water supply and water temperature impacts.
And I'm just going to prove that I was listening to you, Craig, and some of the things that you mentioned could have a power impact. Yeah.
Anyone else on the panel have thoughts? Okay, I'm going to come back to, yes, come on up.
Just to build on what you said, Craig, that relationship between water supply and the temperature management infrastructure and storage being a component of that temperature management, that as that relates to water supply, they are beneficial for each other. That increased storage helps temperature and helps regional water supply reliability, just to make that clear.
Thank you. Coming back to the queue, Leo, and then I'll go to you, Tim Murphy. Leo.
Yeah, thank you. I just want to tie a couple of things together. Gary Bardini mentioned in his presentation that to look for a general fix that would benefit temperature and water supply, where it'd be in the order of 15 to 20 years. I didn't hear your answer, Gary, on how long getting a TCD would take place, but I'm sure it's not going to happen in the next 5 years. Tom's suggestion about a value planning workshop looking at all the potential solutions is a good one, but I have a variation to that. So I will argue that temperature is probably the greatest challenge the water forum faces. And it does affect water supply. If you release too much water to bring down the temperature, that's water being released from storage, unless it can be picked up somewhere else and used by the entity, by an entity from which it was released, it's going to belong to somebody else. Looking at 15, 20, we're looking at 15, 20 years for a long-term solution set. Fish are on a different time scale. I think I mentioned that before. Their time scale is now. It's year after year. It's this year, it's next year, and the subsequent years. What I'd like to suggest from the Water Forum is a value planning workshop that looks at activities or actions or management actions that can be implemented immediately within the next 1 to 3 years, for example. That limits our supply of options, but that's fine. As mentioned on the panel, we can't disregard any tools, and some of the tools we can use immediately will help us get to those longer term tools. So I think that's something we should be seriously thinking about. And if it means putting together a lump sum of money because, as Erica suggested, we're going to have to operate the power bypass every 8 out of 10 years, then let's start doing that. Let's start thinking about that. It's only money. Okay, anyhow, that's my suggestion.
Good suggestion, thank you. Tim?
Yeah, a couple of things. One.
Oh, sorry, panel?
Oh.
Oh,
sorry,
Tim.
wrong Tim.
Go ahead.
Wrong Tim.
Yeah, I was talking to Tim Murphy, but did you have something?
Okay.
Tim, okay, over to Tim Murphy.
So question for Erica regarding the temperature compliance point slide that you had. Seeing where Hazel and Watt Avenue fell with those temperature scales that are important for the salmonid health and their spawning and everything, couldn't help but notice, the faded gray line in the background that showed Rio Vista. With that slide, those were really elevated temperatures, and I don't know if it is a time of year or spawning cycle issue, but it looks like we can do all these things to address temperature in the Lower American River, but am I understanding that right? The Rio Vista temperature levels are still really elevated beyond the health of the salmonids. Are our efforts for the Lower American River going to be negated by Rio Vista water temperatures?
I would say not necessarily so, but Chris, would you want to tack on, having conducted more of the temperature modeling in the past, just thinking, we know that we're getting to these temperatures at Rio Vista. It can be somewhat of a barrier, but we do know that fish come through. So I think that hasn't really been studied, the downstream effects and what is going on there. And it depends a lot on when our fish are coming in, just a context before Chris talks, it depends a lot on when the fish get here and how mature they are and there's a lot, right? Because this is all happening over, everything biological has a lot of nuances. So they can start coming into the system in the summer and move very slowly up the system, or they might come in later and, closer into the fall, closer into spawning period and move quickly. So it depends a lot on what the exact temperature or conditions are for that particular fish.
So I understand it might be part of the cycle, but as Chris answers, I'm just curious about if they're getting through Rio Vista water, why can't they get through our water?
Well, it comes down to what the fish are using in different parts of the system. And so Rio Vista is primarily a migration corridor, so they're passing through it, but they're not trying to spend long periods of time there. So they are accruing some thermal exposure, but if they're just passing through it through the course of a couple of days or a week, that's a lot less of an impact than if they're holding there, trying to spawn there, their eggs would die, trying to rear there, they would be susceptible to bacterial infections and other diseases. And so it really, is the warm temperature down there a good thing? Absolutely not. But if we can't get it cold enough for them to successfully spawn and successfully rear here, they're not going to even have a chance to run that gauntlet.
Okay, and
it's also what we have control over. We can't really impact change on the.
Have there been any studies as the salmon pass through the Rio Vista? They're not hanging out there, so I understand that aspect to it. But is there anything any kind of aggregated impact that passing through that warmer water to get into our hopefully someday colder water that's healthier for them, that is going to cause any species health degradation.
I don't know of any studies that have happened. It clearly affects timing, though, right? If it's warm down there at Rio Vista, they can wait until it's a little cooler later in the year. It affects the timing that they get into the American River. The American River, where every year we're fighting fall temperatures for fall run Chinook salmon. So we're trying to get temperatures down to this year to 60 degrees in mid-October, and then try to get temperatures down to 56 for spawning. But it's a challenge every year to make that happen, and that's where this power bypass has been used in the past. There's 30,000 acre-feet of cold water in the lower part of Folsom Reservoir that's not accessed by the powerhouses. And so almost every year we've started to release that in October and November to get temperatures down for successful holding in early October and successful spawning in late October and then through November.
Thank you for the questions. Tim Washburn, did you have something?
Yes, I did. I wanted to ask two questions. One is, Tom, you mentioned Aerojet, producing water and putting it in the river. What do we know about the interplay between the river and the groundwater, and does the point of extraction of groundwater have an effect on lower river temperatures? And could we maybe think a little bit more about that question of groundwater, surface water interaction and where we are actually extracting groundwater? I don't know the answer to that, but it might be one of your all of the above. The other one is along Leo's line. I mean, it seems pretty clear here that the low-level, releases are that's a low-hanging fruit. It's money. So, where are we with VA, for example? I mean, it's hard to get endowments out of public bond money and whatever, but the VA is a little different, and that's a pretty big bang for their buck. Maybe there's something there. If it has to be more capital investment, is it possible to do a solar array project with capital money? Okay, a solar array will exchange, and that's how we pay for it. So now we can borrow money, build a solar array, and bypass the generation of power at Folsom when appropriate. What about that?
I would put those ideas on that list. That's things that people have brought up over the years. We haven't been studied, but we should take a second look. As far as the dynamics between groundwater along the American River and extraction of groundwater that's doing other things and how that's interacting the river. We have the tools. We have some of the tools to look at that, but the groundwater tool that a lot of us are familiar with, it's called Kasana, right? That's a big regional model, and the kind of model you're talking about is a fine-grained, more site-specific model. So, money, and could be looked at.
I guess the question would be those who understand. Would they say, "Oh, maybe there's something there," or would they say, "You're wasting your time"?
Well, that's kind of the beauty of this value planning thing, is that it says over a really short period of time, sorry if I'm just really stuck on this, in a short period of time, bring knowledgeable people in, and they do some sort of professional judgment things, and then it puts them on paper to signal whether they're worthy of more investment.
Thank you. Ron and then Tim Murphy, and was it on this thread? Okay, then let's go to Tim. Sorry to break the queue, and then Ron, go ahead.
Just to volunteer to answer part of Tim's question, I used to work for Aerojet as their director of corporate responsibility and worked very closely with the environmental department. The area in the groundwater zones where they're extracting groundwater for their environmental treatment are down in the very lower levels. So given that the water collection at that level is three-dimensional, I mean, it's not grabbing from below, it's grabbing from around. But I would seriously doubt that there would be an impact on water temperature from the surface. We have invited Scott Goulart, who is Aerojet's environmental director, to be a participant on the business caucus in our conversations, and we can follow up with that question to confirm that. But just from my recollection, I don't believe that would be an impact on water temperature.
Thank you for that, Tim. Coming back to you, Ron, and then I'd like to check in because we are running low on time. Then I'd like to check in with anyone who hasn't spoken today who might have a question or something to offer. Go ahead, Ron.
This is on the same thread. I was going to ask the same question that Tim just did. The representative, the longtime representative from SMUD to the Water Forum, did look at or did have an opinion. Paul Olmsted he had opinion on many things, but one of his opinions was with regard to the setting up a power bypass fund. His reaction was, I think, somewhat similar to Tim's. That is that a capital project, either a solar array or, in Paul's world, a natural gas plant, would be something that could be counted on to be able to mitigate for the loss of power. And remember that in the fall, there often isn't a lot of water in Folsom to be released, and the reservoir level is down. So the actual amount of kilowatt hours that can be produced in kilowatts isn't as much as it would be in other times of the year. So anyhow, that was Paul's perspective, and he was the SMUD guy.
Could I just add to that? I mean, the solar array would also be helpful in many overdrafted groundwater basins as a compensation for taking some land out of production as well. So you could think of it that way too. You know, it's got multiple potential benefits and a way to fund this more reliably without a big lump sum all at once.
But I don't hear anyone talking about the giant sup.
It's okay.
Can I just add one thing?
Yes, go ahead.
Irrespective of the giant sup. So I think it'd be remiss if we didn't just mention RWA and Waterform are advocating in the reconsultation of the current biological opinion for a higher level of carryover. I wouldn't give it a particular odds of being successful, but that would be another cold water benefit if we're able to accomplish that. So.
Thank you, Anne. So is there anyone who really hasn't had a chance to speak, who's interested in asking a question or offering a thought online or in the room? Okay, that was a really engaging conversation about an incredibly challenging issue on the Lower American River. I'd like to thank the panel for your excellent presentations, and you, Gary, for coming up and being an honorary member as well, and for all of your work organizing the panel, Anne. Thank you all. So applause. Before we have some closing thoughts, I know we have at least one disclosure from Jim Pfeiffer. Jim, if you want to offer disclosure. And did you have something, Rob?
Yeah, I'm wondering whether these presentations,